Proving trigonometric identities part 2. There is one other video where I have proved some trigonometric identities, and in that video I showed some general recommendations for proving trigonometric identities. We need to have some background knowledge, and the thing that we need to remember are some of the things from trigonometry and some from algebra. So here are the general recommendations. Change all the trig functions to sines and cosines. So if you see cosecant, secant, tan, and cot, generally writing them in terms of sines and cosines is going to be helpful. And then remember this Pythagorean identity, cos square plus sine square equals 1. If you remember the other two Pythagorean identities, that's great. But at the bare minimum, you got to remember this one, because this will be used so much in problems. And then from algebra, you want to remember the difference of squares formula. If you multiply quantities that look like this, a minus b times a plus b, you're going to get a square minus b square. And finally, I said to combine two fractions. So if you need to add two fractions, a over b plus c over d, then you can cross multiply to get the numerator. So look, the answer is, if you are adding a over b plus c over d, then to get the numerator you can cross multiply ad plus bc. That's how you can get the numerator. And to get the denominator, you simply multiply the denominators, bd, b times d. So these are the general recommendations that you definitely want to know, and there may be more depending on the type of problem, but these are the basic minimum. Now let's look at this problem. We need to prove that secant to the 4 minus tan to the 4 equals secant square plus tan square. And how do you prove an identity? You can start on the left and arrive at the right, or you can start at the right and arrive at the left. Or you can simplify the left side and right side to the same thing. Now, when I look at the left side, I see that it's secant to the 4 minus tan to the 4. So let me rewrite my left side of the problem. So left is equal to secant to the 4 theta minus tan to the 4 theta. Now notice that if you have a minus, then you want to think difference of squares. And of course, secant to the 4 is the square of secant square theta. So I can rewrite this as secant square square minus tan square square. Now if you recall a square minus b square, that could be factored as a minus b. So a is secant square and b is tan square. So this is our a minus b part, and this is going to be our a plus b, secant square plus tan square. And also take a quick look at the right side. The right side is just the second factor. So if you remember your Pythagorean identity, secant square equals 1 plus tan square, then you can realize that this is just a 1. So this is 1, and this is secant square theta plus tan square theta. And that is equal to the right side. Now, if you don't remember secant square equals 1 plus tan square, you could have converted this to sines and cosines, but then that would take it a little bit longer. And the other thing you should do is look at the right side as well. And if the right side is just this factor, then this would have to be equal to 1. And then you might ask yourself, oh, is secant square minus tan square equal to 1? And then if you rewrite that, you will see that secant square equals 1 plus tan square. All right, so this is one problem I wanted to do. Let's look at one other. cosine theta over 1 minus sine theta is equal to sine theta minus cosecant theta over cos theta minus cot theta. Now, when I look at this problem, it looks like I want to start on the right side because right side has cosecant and cot, which could be converted to sines and cosines. If I started at the left, I don't see a way to arrive at the right side. But maybe I want to start on the right side of the equation. So the right side is sine theta minus cosecant theta over cos theta minus cot theta. So this is a fraction where the numerator is sine theta minus cosecant theta is 1 over sine theta, and the denominator is cos theta minus cot theta. So cos theta minus cot is cosine over sine. Now I need to simplify this. So let's flip it over and write down. So notice what you get in the numerator. How do you subtract sine theta minus 1 over sine theta? You can think of sine theta as sine theta over 1, and then you remember the cross multiplying part. Sine theta times sine theta is sine square theta minus 1 times 1 is just 1. So the numerator is sine square theta minus 1 over, well, if I multiply these denominators, I get 1 times sine theta. So that is just sine theta. Now, similarly, if I were to work here in the denominator, cross multiplying will give me cos theta sine theta minus 1 times cos theta. So let me write that down. Cos theta sine theta minus cos theta. So cos theta sine theta minus cos theta over the denominator is just 1 times sine theta, which is just sine theta. All right, so now I have this complex fraction that I need to simplify. So I'll keep the numerator fraction, sine square theta minus 1 over sine theta. And if I have to divide by this, that's same as flipping the fraction and multiplying. So sine theta over, now notice here I could actually factor cos theta, and then I get sine theta minus 1. Now it's time to cancel this sine theta and that sine theta. And you also want to pay attention to the left side. Left side is cos theta over 1 minus sine theta. Are we getting something like that? Not yet. But we need cos theta in the numerator and 1 minus sine theta. Now, so the numerator is sine square theta minus 1. Sine square theta minus 1 is negative cos square theta because 1 minus sine square would be cos square. This is coming from the Pythagorean identity. Divided by cos theta times sine theta minus 1. Now if I cancel out one of the cosine theta in the numerator with the 1 in the denominator, I get negative cos theta over sine theta minus 1. Now does this look like our left side? Well, the left side is positive cos theta. Here I have negative cos theta. So now notice that I could rewrite this expression as negative cos theta over negative of 1 minus sine theta. And if I cancel the negatives, then this exactly looks like the left side, which is what we wanted to prove. So this is equal to the left side. All right, then there's one other problem I want to do. So let's call it number 3. It's 1 over or it says prove 1 over secant theta plus tan theta plus 1 over secant theta minus tan theta is equal to 2 secant theta. Now the right side looks really simple. So let's start with the left side and we might be able to arrive at the right side. Now, you could convert to sines and cosines, but you have to add these two fractions. So let's go ahead and first add the fractions. Cross multiplying will give me 1 times that is just, so this is going to be a fraction which is secant theta minus tan theta. If I'm cross multiplying, 1 times that plus I got to multiply 1 times secant theta plus tan theta. So I did not copy the left side, but I'm just combining these two fractions first. And then the denominator is the product of these denominators, which is secant theta plus tan theta times secant theta minus tan theta. All right, so let's go ahead and simplify the numerator. Let's keep the denominator all right, let's first simplify the numerator. This is secant theta plus secant theta, so that is 2 secant theta. And then negative tan theta plus tan theta, they cancel each other out. And look at the denominator. It says secant theta plus tan theta, secant theta minus tan theta. Now you can invoke the difference of squares formula. You get secant square theta minus tan square theta. And now notice the right side is just 2 secant theta. But what we have so far is 2 secant theta over something. Now that something would have to be 1. And if you remember the Pythagorean identity secant square equals 1 plus tan square, then you know that this is going to be equal to 1. So this is equal to the right side. So knowing your identities, the more identities you know, the faster you can get. Now, if you don't see that this is equal to 1, you probably would have to convert this to sines and cosines, and then knowing the fact that sine square plus cos square equals 1 will get you to the answer. But it would take several steps.